Advent of Code 2024, day 19, linen layout. This is OXDF. Let's take a look. Basically, I'm going to get, the input's going to have two sections. The first section is a single line, comma space separated of colors. So our colors are represented by single characters. White is W, blue is U, black is B, R is red, green is G. And so we have towels with these, we can make these stripes. So we can make a red, we can make a white red, we can make a blue, a green, a blue, white, black, white, blue, a red, black, green, black, and black, red. And so then we need to look at each of these target patterns and see if we can assemble that with the stripes we have. So for example, we can get the first one if we take the B, the R, the WR, and then the R, and we're good. We can reuse patterns. We have an unlimited supply of things on the top line. But for example, we cannot create UBWU because there's no single U. So there's nothing that starts with U. So I can't make that stripe. So the first challenge is to go through all of our input and calculate how many of these patterns are possible. And so of those 8, there are 6. Let's grab this so we have it. And look over here, and I will genday 19. And this script just pulls the sample input. Well, no, it pulls my input for me. It gives me a sample input to save as, and it gives me a stub here to work off of. Let's take a look at the input. Significantly more, like a lot of patterns here, and hundreds of like 400, well, probably 400 targets. I'm hoping we can do this with string parsing. So, but we'll see. Let's give it a look here. So I'm going to start with options equals f dot read line. Going to read a single line dot strip dot split on that. And I think that will give me the options. Let's just double check. I always like to make sure I'm not doing something crazy, because if you don't check this and then it was broken, then you get far into the challenge and it's not working like you want it to. So that looks about right. Now we can do f.read line and just skip the empty line. And now we can do f.read. No, I'm going to strip off any trailing white space. Dot split on new line. And I will call this targets. So now I've got targets in. I guess we can check that as well. Save, run. That looks good. Okay. So how are we going to check targets? I'm going to use a function. We're going to use recursion here. We're going to hope this is going to. I'm going to hope we have enough. The recursion is not too big, and that string operations are not too small. So the idea is we're going to say valid target. Target string returns a bool. And what we're basically going to do is we're going to say for option in options, if target dot starts with option. So like if the target string starts with the option we're currently looking at, and we can't just only check that, but we have to, if that's the case, I guess we can say, and if that's the case, then we'll say if valid target len option onwards return true. So if the target starts with an option and the rest of it after it is valid, we return true. And we can't just return this, because if it's false, we could hit another starting point that works, and then we might want to check that as well. So that's good. We now need if we get through all the options and we haven't returned true, we return false, and we need a base case. And so our base case is going to be if target in options return true. So if we get down to the point where all that's left is one of the options, then we can definitely return true. And I think that might be all we need. So now let's see, let's count this up. So we'll say valid target of t. Say we'll do a len of t for t in targets if valid target.t, and we're going to need parentheses there. So we're going to loop over all of the targets and just keep the target only if it's valid, and then we'll just keep the length of that. And so if we do this, we get 6, which was our expected answer. The question is, will this run in reasonable time? And the answer appears to be yes. So 355, let's check that out. Awesome. All right, on to part 2. Okay, so we don't need to just return true or false. We basically need to get a count of the number of ways that we can make each pattern. So, this one can be made with, at the end, it could be BR or it can be the BR pattern, because both of those things were in the example. So there's the B and the BR. So we need to count. So this doesn't seem too much worse. Let's start by refactoring part 1. So we'll change this to an int. If target is in options, I don't think for the exact answer I just had a minute ago, I think I need to change this. So we're going to say if target, let's just do if target equals empty string, return 1. And that way we'll still be putting all the options through it, because what I'm worried about is if I get to the end and I've got a BR, I don't want to just be like, oh, return 1, because it could be the BR or it could be the B and the R. Hopefully that makes sense. So for options, if target starts, if valid target, so we're just going to need a count equals 0. And so we'll say, if it starts with the option, count plus equals valid target of target then option onwards. And then we return count. Now this will still be fine for part 1, because all we need to do here, let's come down here and say, maybe I should rename, it's no longer valid target, rename symbol, count, combinations. Okay, so now we're going to say combinations, then what, count combinations equals, and we'll say T, count combinations of T for T in targets. And this one, we're going to say C1, whatever, C for C in combinations if C greater than not equal 0. So if it's 0, we want to leave it out, and then we just get the length. So in theory, we should still have 355 here. We got 1. So we are going to turn it down. See what common, I guess we can check example. Part 1 equals combinations. Made it a generator. Oh, that looks better. Get rid of you. That was just a silly mistake. 6 and aha. Okay, so this is running a long time. I think anytime you do recursion, we want to look at, I probably should have done this from the start, but from functools import cache, it used to be called like LRU cache. But if we basically want to add the cache, so this function takes a string. And the fact is that anytime it gets a string ABCD, it's going to return the same result. And I don't need to check that string over and over again. But in this input, I'm going to run across the same possibilities over and over again. So cache will just say, if you get the string ABCD and you've seen that before, and you haven't seen it before, run this function, return. But when you return, store that in my cache. So the next time I come back to this, if I get the same string, I can just stop. And so that means I could have some pretty long strings in my cache that I just all of a sudden cut all those runs out. Let's see if this works. Beautiful, much faster. And so now we can say part 2 is going to be some combinations. Is that simple? Is that what I want? Yeah, I think so. Let's give it a try. Boom. That was not bad at all. So, all right, yeah, that's basically it. We're just going to use recursion to figure this out. Thanks for hanging out with me today. I'll be back tomorrow.